Hi everyone, we're Mifril Security, a deep tech startup specializing in cybersecurity solutions to ensure data confidentiality and model protection in AI processes. Today I want to give you a quick walkthrough of our main product, which is designed to help you to deploy confidential AI workloads. So what do we mean by confidential AI exactly? Confidential AI refers to using hardened environments to ensure complete data isolation and encryption. By employing a tested TLS, data is only sent upon a secure TLS channel established between the hardened server environment and the client, preventing exposure to, say, malicious servers that could intercept and forward client data. It also preserves code integrity, meaning that you can prove the code running on the server is authentic and uncompromised. This allows users to verify that they're communicating with a server that hosts the expected code and model. Let's take a moment to just talk about what BlindLlama actually is. BlindLlama is a technical framework which aims to both make AI confidential and provide technical proof of this. It provides a confidential AI system using trusted platform modules, or TPMs, to measure and verify the code deployed. We're able to do this thanks to two key elements. On the server side, we have an isolated hardened environment that wraps the open source LLM in what we call a secure enclave. This is a privacy-enhancing technology designed to isolate and encrypt both the user data sent to the model and the model itself, guaranteeing confidentiality. Enclaves provide cryptographic verification called attestation to prove that the correct code and security features are in use, ensuring code integrity. And then on the client side, we have a Python SDK, which is then responsible for verifying that it is communicating with this genuine hardened environment and securely transmitting communications. With BlindLlama, like with a typical API setup, we still have to trust the cloud provider's hardware and its hypervisor. However, we deploy an auditable OS and server-side code, as well as giving users technical guarantees of the security practices of the AI provider, and therefore we no longer have to blindly trust the AI provider. So let's now talk a bit about how this works under the hood. So BlindLlama operates by deploying an attestation server that loads a hardened AI container which serves the model and generates the cryptographic proof file using TPMs. The TPMs measure the whole stack of the machine and the code that it serves. Before a user's query is sent to the server, the client first verifies that it's communicating with a hardened environment through a reverse proxy that forwards the communication using a tested TLS. This process, known as attestation, involves inspecting whether the cryptographic certificate matches the TLS certificate of the current connection. Note that the associated private TLS key lives inside the hardened environment and never leaves it. Only after these verifications are successfully completed will it send data for AI inference. While other solutions may also claim to put their own security measures in place, they usually provide no technical evidence of this, and we often lack transparency over what these measures actually are. With BlindLlama, the security and privacy properties are derived from the system integrity and the system design. Therefore, the trustworthiness of our service is derived from the trustworthiness of our code. So I know I've given quite a lot of information up to this point, so let's now get stuck in and see a demo. I've already created an OS disk containing the Mifril OS and my application disk, which contains a simple API for a Llama 2 7B model. I'll now show you the setup from this point onwards, so we'll start by uploading the disk to create our virtual machine and establishing a connection. We'll use our open source upload script to do this, which is going to create both a lower disk and an application disk. So this local setup can be a bit limiting, as it means the deployment workload has to be static and it can't be easily modified, but it's useful for the purposes of our demo. Once the VM is created on an Azure instance, we generate the measurements for both the operating system and the application disk. These measurements ensure the VM's integrity by comparing locally generated PCR, that's Platform Configuration Register measurements, with those of our cloud VM. Using our client, we can connect to the server, verifying the session with TPM-based attestation. The session is then validated through a process that includes verifying signatures and comparing measurements, and if the verification fails at any point, the session will be terminated. Finally, we run a sample script to validate the report and output a prompt. So in this demo, we query our model with "what is machine learning?" and we get back a comprehensive answer from the model. So this has been a quick demonstration of BlindLlama. The source code is open source and easily verifiable. You can see it by going and checking out our GitHub repo. Thanks for listening.